Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 5 of a unit Laws of Motion. So let's begin with today's class. In today's class we are going to discuss about the common forces and mechanics. So which forces we are going to discuss? Let's have a look. First we are going to discuss about the weight, then normal force, then tension force, then frictional forces. Yes, these are the primary forces. These are the primary forces that we are going to discuss. So let's discuss them one by one. And please, I request you guys to attend this lecture very carefully, as we are going to use this forces in same manner for class 11 as well as class 12. Yes, every time it would be there, every time the rules would be the same. So here in today's class we are going to discuss about the rules of each forces, that how they act, where they act, when they act, when to act and when not to apply. Yes, so please attend this session very carefully. Yes, let's begin. First, weight. We can say it is force acting by an earth. It is the force that is acting by an earth on the object. It always attracts an object towards the center of an earth. And magnitude of this force is m into g, where m, it is the mass of an object, and g, it's an acceleration due to gravity. G is the acceleration due to gravity. So the situation would be something like this. Let's suppose this is earth, and on the earth I have put a certain object and its mass is m. So on this mass a force is being acted. Generally this is the center to center force, and this force is acting in the downward direction. But this is the word, the downward direction is not always true, because for some person who are residing over here, their force would be, their mg would be in this direction. Let's suppose there are certain people who are residing over here, so their mg would be in this direction. Those who are here, their mg would be in this direction. So the correct statement is this force always acts towards the center of an earth. This will always correct. Look at this, all are towards the center of an earth, and this force is always attractive. This force is always attractive, as well as its value would be equals to m into g. Is it clear? Let's say, suppose the situation is something like this, that let's suppose a block is there, and the block has been placed on certain table, and the block is having a mass m. So its weight will be in downward direction, because it is pointing towards the center of an earth, and this would be its weight. that can be calculated as weight is equals to mg. Is it clear? Is it clear? Are you sure? Let's suppose a wage is there, and this is angle theta, this is angle theta, and let's suppose a certain block is there having mass m. So in this situation, mg, it's from center, it is acting in this direction. This is the mg. I hope these things are clear. So if this is mg, this is theta, this is the 90, and this could be written as 90 minus of theta. If this is 90 minus theta, this could be theta. I hope these things are clear. Yes, so if I wish, I can divide this mg into its two of the segments. It's mg cos theta, and this is mg sin theta. Is it clear? Is it? So basically I must know where mg is to be acted. Yes, what should be its direction? Its direction would be towards the center of the earth. Generally we take it from the center of the body to the center of the earth. Yes, it's a central forces. Every object that do exist on an earth, is having mass m, and when it is having mass m, it must be having weight. I hope these things are clear. Any doubts? Is there anything? No? So shall we move to the next force? Let's have a look. It's a normal reaction force. Yes, generally we call it as a normal force. So let's have a look that how does it act. What we say about the normal is, it is the forces which are exerted only when two bodies are in contact. This is required. This is to be remembered, are called the contact forces. So these are the forces which will be acting when two or more than two bodies are in contact. It means, even you understand this, if no contact between bodies, that means no normal force. If two bodies are not in contact, that means no normal force would be acting between these two bodies. But if two bodies are in contact, with each other, then there must be a normal force acting between these two bodies, and this force satisfies Newton's third law of motion. What is it? Yes, the Newton's third law of motion says that action and reaction are of equal magnitude, but they are acting in opposite directions. Yes, so they satisfy the Newton's third law of motion. It depends only on the nature of contact, but not on the area of contact. So it depends on the nature of contact. Yes, whether it is smooth, whether it is rough, and something like that. The component of the contact force normal to the surface in contact is called the normal reaction. That means normal force always acts perpendicular to the surface. It always acts perpendicular to the surface in contact. It always acts perpendicular to the surface in contact. So this is to be remembered. First thing, very important, that it do exist when there is a contact. It does not exist when there is no contact. And second thing, yes, that it always acts perpendicular to the surface in contact. Next, in general, all the surfaces are rough at a microscopic level, when we discuss at the microscopic level. So if you understand this situation, that let's suppose this is table and on this table a certain book has been kept. So if I see this situation at a very microscopic level, then I can understand that this is the surface of the book and this must be the surface of the table. That on a macroscopic level it is smooth, but on a microscopic level all the surfaces are rough, they are not 100% smooth. So in general all the surfaces are rough at microscopic level, and the actual points of contact are difficult to be ascertained because there are so many contact points would be there, and we cannot understood that which is to be taken and which is not to be taken. Even it is not possible to resolve them. Yes, so it is difficult to know the magnitudes and direction of all these contact forces, but resultant of this forces can be definitely taken. Resultant of this forces can be calculated. So let's see that how we are going to catch the resultant force, or the how I can identify that in which direction normal force is acting. So let's suppose consider that a block is there, and this block is having mass m and it is resting, that means it is not moving on a surface as shown in the figure. So which forces are acting on this system? First, it's a weight, that is the mg, and it acts vertically downward, yes, towards the center of the earth. So this is the m into g force that is acting on the block. Second, as you can see that this is the table and this is the book, these two are in contact with each other. These two bodies are in contact with each other, and when these two bodies are in contact with each other, that means this table will must act the normal force, and that normal force will be perpendicular. This normal force will be the perpendicular to the surface. So let the vertical component of this resultant force would be the contact force that we call as a contact force, and let's denote it by n. Is it clear? So thus we can identify the direction and the value of the normal force. Now value, as the body has no vertical motion, situation was something like this, that here one of the force was the mg, here the other force was the n. Does body moving in upward direction? No. Does body is moving in downward direction? No. So as body is not moving anywhere, what I can write, it's a n equals to mg. So these are the balanced forces that we have discussed previously as well. These are the balanced forces. This has been discussed in previous cases. So these are the balanced forces, and since it is perpendicular to the plane of contact, so it is the perpendicular to the plane of contact, it is known as the normal reaction. Yes, so basically if I identify the correct physics, then normal reaction is the resultant contact force acting on a body placed on a rigid surface which is perpendicular to the plane of contact. It is the normal reaction. So is it clear? Is it any doubts? Anything? No? Great. Normal reaction depends only on the nature of the contact and not depends on the area of contact. It does not depend on the area of contact. Even in the event of the motion of the body of the surfaces, this force remains same. Yes, even if object is in motion, the normal force remains the same because it is the force acting because of contact between two forces, contact between two surfaces. Yes, great. So let's look at this situation. In this situation, a wedge is given, and on this wedge, a block has been placed. So we have done this. It's an mg cos theta and mg sin theta. So that might you know. It's a theta. So this is 90. This is 90 minus theta. This would be the theta. Here the force mg would be acting. That you know. So this is mg cos theta and this is mg sin theta. Now the question is, where is the normal force? So what I understand is, and what we understand is, that always normal force is perpendicular to the area of contact. Yes, so this is the surface which is in contact, and from here perpendicular has been plotted, and this perpendicular force is considered as the normal force. Yes, if I want to write the conditions of equilibrium, if I want to write the conditions of equilibrium, then I can say that normal force is in this direction. Mg cos theta is exactly 180 degree from the normal force. Yes, so if my object and if my body is at rest, I can say that n is equals to mg cos theta, and there is no doubt in it. Is it clear? Is it? So do you clear with the normal force? Are you sure? Let's check it out. What does it say? It says a body lies on the table and its weight is balanced by the, yes, so the situation is its mass m. So let's just apply the all the forces that we know up till now. It's an one of the force which is an mg. Another force, as you can see, these two are in contact. So when it is in contact, you need to apply a normal force which is perpendicular, to the surface that is in contact. Yes, so this is n, this is mg, and we can say it's an n equals to mg, which balances each other. So its weight is balanced by the normal force. This would be the correct answer. Yes, let's look at the next question. Normal reaction force is perpendicular to the tangent drawn to the surface. Yes, this is perpendicular to the tangent. This is 90 degree. I hope these things are clear. Is it clear? Any doubts? Any issues? No? Great. Now let's just check it out, where normal force and how normal force can be acted. Let's suppose a certain step kind of mechanism is there, and in the step kind of mechanism, one of the object is in contact like this. So plot the normal forces for this situation. So what I understand is that this body is in contact at this point. So from here you need to plot a perpendicular which is an n1. Let's suppose this body is in contact with this as well. So here it's an n2. So what you need to do, you need to make a vector addition of n1 and n2 to calculate the n. Is it clear? So always remember that number of surfaces are in contact with the body will give those numbers of contact forces, or we can say here it's a normal forces. So as many surfaces are in contact, those many normals is to be designed. When we design the normal force, when we apply the normal force, we need to remember only one thing, that the two bodies should be in contact, and this force should be applied in the direction which is perpendicular to the area of contact or to the side of a contact. Now let's suppose, and one of the object is like this, it is lying like this. So if you observe this very carefully, here one of the point would be there which is in contact. So what you can do is, for your reference purpose, you can have one tangent, and from this tangent you can have one normal force over here. So here in this situation, only one of the body is in contact, only one of the point is in contact, and when only a single point is in contact, normal force could be applied in this direction. Is it clear? Is it clear? Are you sure? Great. So can we move to the next sessions? Yes. Let's suppose a situation is something like this. Yes, these two blocks are there. This is M1, this is M2. Yes, at this point of time, I understand that even the ground, even this table will apply a force of normal reaction with each other. But here I am interested in M1 and M2, or the normal reaction between M1 and M2 only. So what forces is being acted between M1 and M2? How could I see this? How could I see this? So what I supposed to do is that, let's suppose this is the M1 and M2 and M1 is in contact with this. So M2 will apply the force in this direction. This is the normal force. If I am talking about the M2, then N1 will apply a force of contact in this direction. If you can observe these things very carefully, then you must understand that these are action reaction pairs. Yes, one of the force has been applied by M1 on M2, another force has been applied by M2 on M1. They both are same in magnitude but opposite in direction, and it is a two body interaction. So all the conditions are satisfied, and if all the conditions are satisfied, then you must understand that these are the action and reaction pairs. I hope these things are clear. Yes, is it clear? Yes. So on us, let's summarize this. First, if bodies are in contact, normal would be there. That means normal force would be there. If no contact, that means no normal force. Second, always acts perpendicular to the contact surface. One more, and which is very important, it always acts such as it is going to push the object. It always acts such as it is going to push the object. Yes. So these are the points which we should remember and we should keep in mind while we are applying the normal force from one body to another and so on. So is this clear? Normal is clear? Are you sure? Any issue and any doubts? Any doubts on this? No? So let's have a look. That suppose the situation is, this is the first body M1 and this is the second body M2. As you can see that these two are in contact. The question is, find out normal force acting between bodies of between M1 and M2 mass. So You need to find out the normal force acting between body M1 and body M2. So what you need to do is look at this. First, are they in contact? Yes. That means normal force must be there. And if normal force must be there, let's suppose this is M1, and on this body M2 is acting this force. So it is going to, like, the force would be going to like this. It's a push kind of force. This is the normal. And if I consider the situation, of M2, then again it's a push kind of force, but that force will be applied, by the body M1. So in this case, this would be the situation. This is the direction of the normal force that is being acted by M1 and M2. Is it clear? Is it? Are you sure? So can you do this? Yes. Are you sure? Okay, great. Now let's understand the concept of free body diagram. It's an FBD. It's a free body diagram. What is it? What do you understand by the free body diagram? Any idea, any clue? No? Let's have a look. Let's go through free body diagram with example. Let's suppose that this is M1 and this is table. They say that plot the FBD. It's a free body diagram of object M1. So I need to plot the free body diagram of this object M1. So what you need to do is, on a first step, just isolate this body. So this is the isolation of this body. Now in this situation, I do not need it to make it explain that what isolation is. Yes, that we better know what isolation is. Yes. So this is the M1. Now you need to apply all the forces which are being acted on this system. So which all forces that are being acted on this body M1? One of the force is M1 into G. Yes, it's a weight force. Who is going to apply this? It's a mass of an earth. Yes, and it's an earth that will apply this force. It's an mg. Now second, as you can see that this table and this book is in contact. So what you need to do is you need to apply a normal force that we call as a normal reaction force between table and M1. So table will apply certain force on M1, and direction of it will be in this direction. It's a table. Yes. Here even you are going to apply a certain force on table, but you are not going to show this. Why? Because this is the FBD of the object M1, not the table. First, let me write down the certain shortcuts to find out the FBD. First, isolate the body whose FBD is required. So isolate that body. Second, mark or show all those forces which are being applied on the body. Here you must understand, not those forces which are being applied by your body. You are not going to consider those force. You are not going to consider those force which is going to be applied by this body M1, but you are going to consider all those forces. You are going to consider all those forces that has been acted on your body whose FBD is required. Is it clear? So will you be able to plot or the have an FBD of any objects to you? Let's just check it out. Let's suppose the situation is something like this, that this is the table and this is body M1. This is another body which is having a mass M2. So these two bodies are there. Their masses are M1 and M2, and I need to plot a free body diagram of this. So let's just begin with the M1. So isolate it. This is M1. Now, which are the forces that is going to be acted on M1 by someone else? First force, it's an mg, weight applied by the earth. Second force, you can see this, that M1 and M2 is in contact. So M2 is going to push this. So it is being applied in this direction. This is the normal. Let's give it a name, normal by second body. It's a N2. Next, even if you observe this carefully, even this two bodies are in contact. Even this two are in contact. So if these two are in contact, this table is trying to push the object. So this is normal due to table. Yes. Anything that remain? Anything? No. That's it. Great. So this is the FBD of the M1. Now let's plot the FBD. Let's have it FBD of M2. So which are the forces that are acting on the M2? One of the force, it's an M2G, it's a weight force. Next M1 and M2 is in contact. Block M1 and block M2 are in contact, and if they are in contact, then the M1 will apply a force on M2, and the direction of this is in this direction, in upward direction, and this could be written as N2. I hope these things are clear. So this is FBD. This is the free body diagram of M1, and this is the free body diagram of M2. Is it clear? Is it any doubts? Any issue? No? So will you be able to make a free body diagram of any situation? Yes. We are going to see that why do we make this free body diagram, but at this point of time it is just the requirement of an hour to make a FBD of the system. I hope these things are clear. Is it clear? Is it clear? Great. So shall we move to the next force of ours? Third force, it's a tension force. What is it and how does it arrive? That you can understand by this situation. That let's suppose this is a block, and that block has been hanged with certain string. This block has been hanged with certain string, and if you understand that this is the mg, that means it is being pulled in the downward direction, or I should rather say towards the center of the earth with a certain force mg. So in this situation, the string will be having certain force acting on it. that force is known as the tension force. This force is considered, or that force is known as the tension force. Yes, when and when string would be there, this would be the case. Even this could be the case when spring would be there. Yes, so either it would be a string or either it would be a spring, a tension force would be there. Yes, where does it acts? It always acts away from the object. It always acts away from the object. Yes, is it clear? Yes. So first thing, when and when you are going to push or pull something, when you are going to push or pull something, and it has been tied up with certain strings or certain spring, that string or spring will be facing or will be experiencing one of the forces, and that force we call it as a tension force. And where does it act? It always acts away from the object. Is it clear? Is it clear? Okay, one more thing. If string is slackened, then tension force will be 0. If string is 0, then tension force will be 0. Suppose the situation is something like this, then there is no tension. Why? Because the string is slackened. So if the string is slackened, there would be no tension force acting on the system. Is it clear? Is it clear? Are you sure? Any doubts or any issue in this? Is there anything? Is there? Are you sure? Great. Let's look at the certain situations where tension is acting. Let's suppose this is engine of a train, and here one more cabin is there, and these two are connected by string. So here let's suppose you are applying a force of external. This is wagon 1. This is wagon 1. Yes. So when you are going to apply a force in this direction, the engine and the wagon 1 has been connected by certain string. So even engine will pull the wagon 1, and due to this pulling force, the tension would be acting on this first, and this would be written as T. I hope these things are clear. Yes, so it is something like this. Let's have a FBD of wagon 1. First thing you need to apply, it's an mg. Second, it's this two are in contact, that means normal due to table. And the third, it's a tension force. How do I come to know that tension force is acting? Because I know that these two wagons are connected by a string, and when engine is going to move in the positive x direction, the string will be in stretch conditions. So tension would be acting in this direction, and it is always the case that tension force is being acted away from the system. Please remember this. If I want to draw the free body diagram of engine, what it would be? First, it would be an mg. Yes, this is the weight of the block, or this is the weight of the engine. It's an mg of engine. Next, engine and earth, they are connected, and as they are connected, you must apply the normal force. It's a normal due to table. Is there anything else? Is there? Yes. If you understand that this string 1 or wagon 1 has been connected with the engines, then you must understood that even the engine has been connected with the wagon 1. And if engine has been connected with the wagon 1, the tension force must be there, and always acts tension always acts away from the system. So this is away from the system. This is the tension that is acting on the engine. This is the free body diagram of the systems, and even now you understand what the tension is. Is it clear? Is it? Are you sure? Can you do this? Great. Let's have one more situation. Suppose the situation is something like this. This is M1, this is M2, and here let's suppose T1 would be there, here a new string, and a new string, that means a new tension. It's a T1 and T2. So what you need to do, you need to just plot the FPD of this situation. Take 30 seconds of time and just plot it without any error. No error should be there. That this M1 and M2 have been hanged from different strings, and they have been hanged, but they are not moving anywhere. Yes, they are at rest. What you need to do, you need to plot the free body diagram of M1 and M2. So the question is, plot the FBD of mass M1 and M2. So what is the situation? Let's just begin with the M2. Which are the forces that are acting? First, it's an M2G. Next, it's in tension. This is tension 2. Anything else? No. They are not in contact with anything, and as they are not in contact with anything, that means no normal needs to be applied. Yes, so there's three forces that we know up till now. It's a normal, it's a relative velocity, cases, certain cases, and the third that is of tension force. So this is T2, and that would be equals to M2G. Now let's have an FBD. Let's have an FBD of M1 block. So this is M1. Yes, which are the forces that are acting? First, it's an M1G. Next, it's a T1. Yes, away from the body, it's a T1. Even now, if you observe the situation, these two blocks are connected by the string, and as they are connected by the string, I need to mention its a tension as well. So this is T2. Let's suppose give it a name as a T2. Yes, and it is acting in the downward direction. Why? Because away from the body. I hope these things are clear. Is it clear? So now will you be able to make the FBD of different situations? Are you sure? Great. Let's look at this. That an object of mass m is suspended vertically by a string of negligible mass from a rigid support as shown in the figure. This is the situation, that something like this, that from rigid support a mass m has been attached, and the mass m has been attached with the string, and that string has been connected with the, let's suppose, a ceiling. So if I want to find it out, the tension in the string, so what I can have is, let's write it down, all the forces that are acting on the mass m. That one of the force that is acting on the mass m, it is of mg, and the other, that is here the string is there. String is going to be stretched, and when it is going to be stretched, tension force would be there, and tension always acts opposite or the away from the body. So it would be acting on this direction. I have make the free body diagram of this, and it seems that this is T, this is mg, and as at this point of time the block is not going anywhere, that means we can say the tension in the string is equals to T is equals to mg. Yes, is it clear? Is it? So let's discuss some more cases of this situation. Suppose let's assume that this system is being pulled upward with an acceleration of a, then the tension in the string. The situation would be something like this, that this was the situation even in the initial. Now this system is being pulled upward. It is moving in upward with an acceleration. So what I need to do is that this is the tension T, this is the mg, this is the mg, and it is moving in the upward direction. So according to the Newton's second law, what I am having, it's a sigma f that should be is equals to mass into acceleration, all those forces that are acting here. Look at this, body is moving in the upward direction, so T must be greater than mg. So what I can have, it's a T minus of mg that should be is equals to ma, and if it is the situation like this, it would be a T is equals to mg plus ma. I hope these things are clear. So from this I have written this, it's a T is equals to m into bracket g plus a. Is it clear? Is it clear? Same way, let's suppose this system is moving in the downward direction with an acceleration a. Now what would be the situation? The situation is that this is mg, the upward, it's a T, and this object is moving downward. So which one is the greater, mg or T? Which one? Any idea? Yes, you are correct. Mg would be the greater, and if mg would be the greater, it would be an mg minus of T that should be is equals to ma, and from this it's a T that should be is equals to mg minus of ma. So this is T which should be equals to m into bracket g minus a. I hope these things are clear. Is it? Is it clear? Let's have the one more relation. So if the string has a mass m, then the tension in the string at the upper end, that means the situation would be something like this. Even this string is having mass m, and this block is having mass m. The situation is something like this. So what happened up till now, my string was always the massless. We always consider that string is a massless, and then all this theory will begin. Now in this case they want that even the string has a mass m. So what you are supposed to do is that you can consider it something like this as well. That let's suppose consider that this is the mass of the string. I have considered it as a block itself, and one more block is there, which is of capital M. And then go with the data. It's let's suppose if system is at rest, then upward force, it would be the tension, and the downward force, it is the mg of this and mg of this. Yes, so this T is equals to mg plus mg. This is the tension. Same way if system is moving upward, suppose if system is moving upward with an acceleration of a, then it could be written as T is equals to m plus a into bracket g plus a. And if system is moving downward with acceleration a, then it could be written as T is equals to m plus m into bracket g minus a. Is it clear? Is it? So this all are the cases, but we cannot remember this. This is not to be remembered, this is to be applied. Yes, this needs to be applied, and what you need to do is you need to understand only the one basics, that is sigma f is equals to m into a, that all the forces or the vector addition of all the forces would be equals to mass into acceleration, mass of the object multiplied by acceleration. I hope these things are clear. Is it? Is it clear? Let's look at one of the more cases. Let's look at this. Suppose masses are connected by a string and suspended from a rigid support. Then the tension in the string when force F is applied down as shown in the figure. This is the situation. This is M1, this is M2, and this is being pulled by this force. So what are the forces that is acting? You can see this that here force F is acting in the downward direction. T1 and T2 are acting in the upward direction. And so what else or what other forces are acting? You can have it's an in the downward direction, that is of M1G. In the downward direction it is an M2G. So again you are going to have the same thing, sigma F, that should be is equals to M into A. But here acceleration is 0. Acceleration is 0, so sigma F would be equals to 0. Now write down all the forces that are acting in upward direction. Let's consider it as a positive. So that could be written as T2 equals to write down all the forces that is acting in the downward direction, M1G, M2G and F. So this could be written as M1G plus M2G plus F. This is equals to the T2. I hope these things are clear. Is it clear? Is it? Are you sure? Great. So ready for the numerical? Ready? Can you do it? Can you? Great. Let's have a look. Go through the data. Have your pen and paper and attempt it. It says that 3 blocks of equal mass, each of 3 kg. This is 3 kg, 3 kg, 3 kg. Yes, are suspended by a weightless string as shown. If if applied force at this position is of 100 Newton, then T1, you need to find out the T1. So just do it. Make it quick. You have 1 minute of time. Please do it quick. Yes. Can it be done? Can it be? No? Not an issue. Let's have a look. That what the situation is, that this 3 kg blocks are there, and when this 3 kg blocks are there, what I understood is that here mg would be acting in this, here again mg would be acting on this, and here again mg would be acting on this. Yes. So when I want a T1 only, so let's have a free body diagram of this system. That this system can be seen like it's a 3 kg block. It has been applied by F external, which is of 100 Newton. One more force, it's an M into G, and in upward direction the tension force is there. Now does it moving anywhere? Not, neither in upward direction nor in the downward direction. So here the sigma F, that should be is equals to mass into acceleration, and acceleration equals to 0. So that is T1 equals to 100 plus mass, it's a 3 multiplied by G, it's a 10. So this is equals to 100 plus 30, which could be written as 130 Newton. That's it. You did it. I hope those things are clear. Is it? Is it clear? Great. So, shall I add something? That in the previous question, find T1 and T2. The situation is this is 3 kg block, and you need to find out T1. You already did it. Now it's a T2 and here it's a T3. So you have find out T1. Now you need to calculate T3 and T2. So how could you do this? So let's have an FBD of 1 by 1. You know that now T1 is equals to 130 Newton. That you know. Yes. So let's have a free body diagram of this is first block, this is second block, and this is third block. Let's have a free body diagram of second block. Isolate it. Here it is. Here one of the tension would be acting, it is in downward direction, that is of T1. One of the tension is acting, that is of T2. One more thing, it's a M into G, that means we can say it's a 3 into G. So T2 would be equals to 3 into G, that is of 30 plus T1. T1 would be of 130 Newton. So this is equals to 30 plus 130. It's a 160 Newton. I hope these things are clear. Is it clear? Is it? So you did one of the task. Now let's work for the next task. It is the force applied on this third block. Tension. So again, this is 3 kg of block. Our tension T3 is acting in the upward direction, T2 is acting in downward direction, and this is M into G. So the total amount of forces that is acting in upward direction should be equals to total amount of forces that is acting in the downward direction, because acceleration is 0. Yes. So this T3 should be equals to T2 plus M into G. This is T2, that is equals to 160 plus M, that is of 3 multiplied by 10, and that should be is equals to 190 Newton. I hope these things are clear. Is it clear? So can you do this kind of questions? Can it be done? Are you sure? Can it be done? Great. So we are going to come back to this, but before we are coming back, we need to discuss some more thing, that is the motion of the connected bodies. Now when we said that it's a motion of connected bodies, you need to understand first principle, that when objects have been connected by some string or some other object or some other thing, then they must be having same acceleration when they are in motion. Yes, this you must understand, that when any objects are there and when they are considered as the connected bodies and they are supposed to be moving. Yes, why? Because certain amount of force is being acted on those systems, and if certain amount of force is acted on the system, and let's suppose they are having then they are having same acceleration to each body, to everybody. Yes, so when they are in motion, they must be having the same acceleration. This is the concept behind the connected bodies. Yes, we must remember this, and this is applicable to every time. Let's have a look. That's suppose that the motion, this is the motion of the connected bodies. uh, Two blocks are there. The two blocks are of masses m1 and m2, and let's suppose you have applied a force F. That means you are going to push the m1 and m2 together with the help of the force of F. So, and let's suppose you want to find it out the normal force, you want to find it out the acceleration and all that stuff. So first task in any of the situations should be to calculate the acceleration. What is acceleration? The acceleration is equals to F divided by m total. Always remember this, that acceleration should be is equals to force applied divided by m total. While you calculate the m total, it would be the addition of m1 plus m2. So this is equals to A is equals to F divided by m1 plus m2. This is equals to acceleration. Now once you get it, once you find it out the acceleration, let's suppose you need to calculate the force acting between these two. Suppose have a free body diagram of this. Let's suppose this is m1. On this m1, one of the forces is acting by the m2 block is the normal force. One of the force is acting, it's an F. In which direction is it moving? In which direction is it moving? In the positive x direction. How could I come to know? Because external force is in this direction. External force is in this direction and it is going to move in this. So what I can have, it's the F minus of n is equals to m1 into A. So the normal force is equals to F minus of m1 into A, and that could be written as F minus m1 multiplied by F divided by m total, which is of m1 plus m2. Now rest of the thing you can do it. Is it clear? Is it clear? So always remember that your first priority and first task would be to calculate the acceleration of the system. Once you did it, you are going to move forward and trying to find out the remaining thing. So first task, always calculate the acceleration of the system, then the remaining things. Yes, like to see one more question based on this. Let's suppose you need to find out the contact force in this system. So here three blocks are there, m1, m2 and m3, and you are going to push them with the help of force F. And let's suppose you need to find out the contact force between m1 and m2, or the contact force between m2 and m3, and something like this. So what you are supposed to do is, let's just calculate the acceleration first. Acceleration could be written as force applied divided by total mass of the body. When I say total mass, it would be an m1 plus m2 plus m3. So this is the acceleration that could be written as A is equals to F divided by m1 plus m2 plus m3. This is the acceleration. Now make a free body diagram of, let's suppose m1. Let's suppose the m1. Which are the forces that are acting? It's a F, and this is the normal force. It is moving in this direction. So what I can have, it's an F minus n is equals to m1 into A. Yes, and from this n could be calculated. Yes, same thing can be done for here as well. I hope those things are clear. Is it clear? Any doubts in this? Anything? So shall we move to the numericals based on this concept? It's in connected motion. Shall we move to this? Okay, look at this. 3 masses of 16 kg, 8 kg and 4 kg are placed in contact as shown in the figure. A force of 140 Newton is applied on 4 kg mass. Then the force on the 16 kg will be this 3 blocks. These 3 blocks are being attached with each other, and you have applied a 140 Newton of forces to the 4 kg object. You need to find out the force on the 16 kg. So first task, what you need to do is you need to find out the acceleration. The acceleration of the system can be given as, this is 140 Newton of force divided by divided by m total. The total mass would be 16 plus 4 plus 8. So this is equals to 140 divided by 16 plus 4, 20, 20 plus 8, it's a 28. And 28 5s are 140, it's a 5 meter per second square. This is the acceleration. Now what else do you require? You require a force acting on the 16 kg of body. So the 16 kg of body, this 16 kg of body will be having this, a certain force F would be acting on this. Let's write it down as an F dash, and this can be written as F dash is equals to mass into acceleration. The mass of the box, it's a 16, acceleration it is of 5, because these are connected bodies and all the bodies must be having same acceleration. So this could be written as 16 into 5, that is of 80 Newton. Is it clear? Is it clear? Are you sure? Yes? Great. Let's look at this question. This is the situation that this is of 3 kg, this is of 2 kg, this is of 5 kg. Yes, and you are going to apply a force of 20 Newton. What do you want? You want that find out. First, acceleration. Next, normal force. It's a, let's suppose N1, and this is N2. Yes, these three are the requirements. We need to find out the acceleration, we need to find out the N1, and we need to find out the N2. So how can we do this? So what I understand, first let's work for the acceleration, which is the F divided by m total, and this m total would be 3 plus 2 plus 5. The force I have applied, it's a 20 Newton, divided by 3 plus 5 8, 8 plus 2 10. This is equals to 20 by 10, which could be written as 2 meter per second square. Is it clear? Is it? Now let's work for the normal forces. So if I draw a free body diagram of 3 kg object, which are the forces that is acting? So what you understand is 20 Newton of force is acting from here, and this 3 kg and this 2 kg, this two body are in contact from here, and as they are in contact, it will apply a normal force. This 2 kg is going to push this in this direction. Now in which direction this object is going to? Positive x, negative x? It is for sure that it is going in positive x direction. Why? Because F external is applied in this. So this is the direction of acceleration. So what you need to do, again a same concept, sigma F is equals to m into ma. This is equals to 20 minus of n2, that should be is equals to m into a, that is 3 into acceleration, which is 2. So this is 20 minus of 6 should be equals to n2, and this n2 could be equals to 14 Newton. I hope this is clear. Is it clear? Is it? Okay, so this is the n2. Now let's work for the n1. You can have this, it's a 5 kg of block. And on the 5 kg of block, here these two are in contact, and once they are in contact, 2 kg is applying a force on 5 kg in this direction. Yes, I am always making the force such as you are going to push someone else. Yes, you always want that this body should be moving in the direction. Yes, it is going to be pushed, and once it is going to be pushed, I can have the normal force and the direction. This is n1, this is its acceleration. Acceleration would be equals to 2 meter per second square. So in horizontal direction, it is having one force only, and here in this case we are interested Here in this case we are interested in its horizontal motion only. So when I supposed to have its horizontal motion, what I can have, it's the n1, that would be equals to 5 into 2, which could be written as 10 Newton. That's it. You did it. Great job. Is it clear? Is it clear? Yes. So can we do this? Can we do this? One more question. Great. Let's have a look. This is of 8 kg. This is of 2 kg. One force is acting in this, that is of 20 Newton. One force is acting in this, it's a 10 Newton. What do you want? You want that, find out contact force between block 8 kg and 2 kg. You need to find out the contact force between block 8 kg and 2 kg. How will you do it? How can it be done? So what I understand, let's just calculate the acceleration first, and the acceleration would be equals to F by m, or I should say it's an F net divided by total mass. It's an 8 kg plus 2 kg. So the F net, this is acting 20 Newton, this is acting 10 Newton, and both are going to press each other. That means it's a 20 minus of 10 divided by 10. It's a 20 minus 10 would be the 10. 10 by 10, it's a 1 meter per second square. I hope these things are clear. Is it clear? Is it clear? Great. Now let's work for the normal force. So what I understand is, let's suppose having a free body diagram of 8 kg block, which are the forces that are acting in the horizontal directions, because at this point of time we are interested in horizontal motion only. So this is the 20 Newton that I can see here. These two bodies are in contact, and that's why 2 kg block is going to push the 8 kg block, something like this. Let's suppose write it as n dash, and this system is moving in this direction with acceleration. So what you can have, it's a 20 minus of n dash, that would be equals to 8 into acceleration. It is a 1 meter per second square. So this is 20 minus of 8, that should be equals to n dash, and this n dash can be written as 12 Newton. This is the contact force between 8 kg and 2 kg. Now it is possible that you have tried it with the 2 kg block. Even then answer would be the same. How? Let's have a look. Let's suppose you have chosen the 2 kg block to get this done, and this is the force, that is the 10 Newton. Now 8 kg block will apply a normal force on this, and I have given it name as an n dash. And this system is moving in this direction. This is the acceleration of the system. So what I can have is the n dash minus of 10 should be is equals to mass into acceleration. Yes, so this is equals to n dash minus 10 should be equals to 2 into 1 meter per second square. This is equals to n dash is equals to 10 plus 2, which should be it's a 12 Newton. That's it. You did it. Great job. I hope those things are clear. Is it? Great. So let's just wind it up this session over here. Yes, we are leaving it at some of the midway, but we cannot extend this session above this timeline. Yes, so what you are supposed to do is just go through this sessions. This complete lecture has been divided in 2 segments. In the next session, even we are doing the connected bodies motion. Yes, so please revise this all things, and before tune up to the next session, practice as many questions as possible, and practice the questions of the normal forces, weight, and all the concepts that you have learned in the previous sessions. Yes, thank you. Have a good day. Take care. Bye bye.